Hello and welcome to our tutorial for Tekla structures. So for those of you who doesn't know what Tekla structure is, Tekla structures is a building information modeling software which is able to model structures that incorporate different kinds of building materials. So it allows structural drafters and engineers to design a building structure and its component using 3D modeling. Tekla Structures is one of the most advanced structural software for building information modeling. So with it, we can create, combine, manage, and distribute accurate multi-material models full of construction information and manage and communicate the design. So for our tutorial video for today, so we will show you how to model beams, frames, and trusses using Tekla structures.
This diagram shows a beam with loadings and supports.
Let's now try to analyze the given beam using Tekla structure. So after opening the Tekla structure, there's a default grid line. Double-click the grid line to change the values. The coordinates should be based on the loads and supports of the given beam. For the X, we'll put 0, space 3 times 4,500, space 2,000, space 2,500, space 1,000, next 3,000, and last is 1,000. For the Y, we only need one grid line, so we'll just put 0. And for Z, we also need only one grid line, so we'll put 0. For the labels, since we have 9 grid lines on the X coordinate, so we'll add 7, 8, and 9. For Y, we only need letter A, since there's only one grid line. And for Z, we only need positive 0. Click Modify, click Yes, then click Close. Now let's create the beam. Under Concrete tab, select Beam, then create a beam from node 1 to node 2, node 2 to node 3, node 3 to node 4, node 4 to node 6, then node 6 to node 9. We created 5 beams to easily put the supports later on. Press Escape. Then next, we'll put the loadings. Under Analysis and Design tab, double-click Load. Change the load form to the triangular one. Change the value of P1Z to negative 12,000. Click Modify, then click OK. So place the load from node 1 to node 3. To easily see the loading, go to Load Groups, then you can change the color. Now I'll choose black for this presentation. Click OK. Next, for the next load, double click on Load. Change the load form to uniformly distributed. Then change the value of P1Z to negative 15,000. Click Modify, then click OK. Place it at node 3 to node 4. Press Escape. So next are the point loads. So under Load, select Point Load. Click at node 5, node 7, and node 8. Press Escape. Then double click the load at node 5 to change the value. Change the value of PZ to negative 10,000. Since we have a moment, we have to change the value of MYY to negative 6,000. Click Modify, then OK. For the load at node 7, double click, then change the value of PZ to negative 15,000. Click Modify, then OK. For the load at node 8, double click on it to change the value of PZ to negative 20,000. Click Modify, then click OK. Now let's put the right supports. So for the first beam, click on it and then click Get Analysis Properties. For the Start Analysis tab, select Supported, then since it is pin supported rather, then we have to change Rx to pin. Then we have to free the UI since there's no load at Y direction. So click Modify, then click OK. For the second beam, Get Analysis Properties. Then for the Start Analysis tab, it should be supported by a roller, so the UX should be free. Then for the End Releases tab, it should be connected and it should be fixed connected. Click Modify and click OK. The first beam also should be connected at the End Releases. It should be fixed connected. Click Modify, then click OK. The third beam is just similar as the second beam. The UX should be free and the releases should be fixed connected. Click Modify, then click OK. For the fourth beam, this is also same as the second and third one. For the Start Releases tab, UX and UI are free and the releases is fixed connected. Click Modify, then click OK. For the last beam, for the Start Releases tab, it is also roller supported, but the End Releases tab, it should be roller supported. So let's select supported, then let's free the UX and UI. Then change the RX, RY, and RZ to pink. Click Modify, then click OK. So let's now analyze the beam. Go to A&D Models, create new, then for the analysis application, choose SAP 2000, then click OK. Click Export. Then since there's no load combinations needed, select No, then select OK. Just wait for the SAP 2000 to open. Just click OK, then go to the SAP 2000. To analyze the beam, under Analyze tab, select Set Load Cases to Run. Since we don't need modal analysis, select the modal, then click Do Not Run Case, then click Run Now. Then there's the deflection of the beam. If you want to see the forces, under Display tab, select Show Forces/Stresses. Click Apply, then click OK. Now that's the reactions at the support of the beam. Thank you for watching. Let's try to analyze the given frame using Tekla structure. After opening the Tekla structure, there is a default grid line. Double-click the grid line to edit the properties. For the coordinates, they should be based on the loadings and supports of the frame. For x, we should have 0, space 2000, space 3000, space 2000, and last 2500. For y, we only need one grid line, so we'll just put 0. And for z, we'll put 0 and space 3 times 3200. For the labels, for x, we only have 5 grid lines, so we'll delete number 6. And for y, we'll delete B to F. For z, we should have positive 0 next positive 3,200, next positive 6,400, then last positive 9,600. Click modify, click yes, then close. Now let's create the beam. Under concrete tab, click beam, then click on node 1 to node 5. Press escape. To move the beam, click the beam, then right click on the screen. Select move special linear. Change the value of DZ to 3200. Click move, then OK. Press escape. Then to copy the beam, click the beam, then right click on the screen. Select copy special linear. Change the value of DZ to 3200. Then for the number of copies, change it to 2. Copy, then OK. Press escape. Then now, let's create the column. Click column, then click on node 1. Press escape, then double click the column to edit the properties. On the position tab, let's change the top level to 9600. Modify, then OK. Now let's copy the column. Right click on the screen, select copy special linear, change the value of DC to 0, then change the value of DX to 7000, change the number of copies to 1, click copy. Then now change the value of DX to 9500, click copy, then OK. Now let's put the loadings. Under analysis and design, double click the load. Then let's change the load form to linearly varying. Then change the value of P1Z to negative 6000 and change the value of P2Z to negative 13,000. Click modify, then OK. Then place it on the top beam. To change the color of the loading, go to load groups, then change the color. Now I'll choose black on this presentation. Click OK. For the second loading, double click the load. Change the load form to uniformly distributed. Change the value of P1Z to negative 12,000. Click modify, then OK. Then place it on the second beam. Press escape. Then for the point loads, under load, select point load. Click on node 2 and node 3 and click on the top beam on the right side and press escape. To change the values, double click on the load. Change the value to negative 15,000. Click modify, then OK. Then the load at node 3, double click, then change the value of PZ to negative 20,000. Click modify, then OK. Now change the value of this load. Change the value of PZ to 0. Change the value of PX to negative 8,000. Click modify, then OK. Now let's move these two loads. Click these two by pressing Ctrl, then right click on the screen, move special linear, then change the value of DC to 3200, then click move, then click OK. Press escape. Then for the last load, double click on the load, Then change the value and change the load form to linearly varying. Then change the value of P1 to 0. Change the value of P1x to 9.6, 9,600 rather. Then change the value of P2x to 0. Then change the value of P2z to 0. Click modify and OK. Now let's place it from node 1 to the top of the beam. Press escape. Now let's modify the supports. Since the 3 columns are fixed connected, click the column, then click get analysis properties. For the start analysis tab, this should be fixed supported. Then on the end analysis tab, this should be fixed connected. Then for the start analysis tab, the UI should be free since there's no load at Y direction, and RY should be pinned. Click modify, then click on the other beam, other column, click modify, then click on the last column, click modify, then click OK. Then let's change the connection of the beam. Click the beam, then click get analysis properties. For the start analysis tab, this should be fixed connected, and for the end analysis, this should be fixed connected also. Click modify, then click the next beam, click modify, then the last beam, click modify, then OK. Now let's analyze the beam. Go to A&D models, create new, then choose sub 2000 as the analysis application. Click OK, then click export. Since there's no load combinations needed on this frame, choose no, then click OK. Just wait for the sub 2000 to open. Just click OK. Then go to the sub 2000. To analyze this one, go to Analyze tab, select Set Load Cases to Run, then click the modal. Since there's no need for modal analysis, click Do Not Run Case, then Run Now. Now there's the deflection of the frame. Then to display the forces, go to this Display tab, click Show Forces / Stresses, click Apply, then OK. Now, there are the support reactions of our frame.
So for the next part, we will try to model this truss using Tekla structures. So first, let's open and create a new model in Tekla structures. So to start off, we must first verify the units and decimals that we'll be using. So to do that, click here, File, then click Settings, Options, then this dialog box or this menu will appear. So let's click this, units and decimals. Let's move this like that. So the options window will show, and click again, units and decimals. Then we will change all the units in terms of meters and kilonewtons. So let's change this into meters, and we will use 3 decimal places. So this represents the decimal places, and this represent the unit. So let's do that. Change this to meter, change this to kilonewton, kilonewton per meter, kilonewton per meter squared, kilonewton meter, like that. For the deformation, it's okay to use or millimeters. So we will change the decimal places into 3. Then click OK. After that, let's change the grid lines in order for us to model the truss faster and more efficient. So to do that, double click a grid line and the grid line dialog box will appear. So for the x coordinates, we will change it to 0, 0, 1.189, then 6 times 1.187. This means that the Tekla structures will create 6 1.187 meter spacing grid lines. And for the last 1.189. So for the x coordinate, it is cumulative, meaning it starts from 0 after creating a grid. So for the z-axis and y-axis, it's different. So you need to specify the coordinate. So for the y-axis, since we're only creating a plane truss, we will make this as 0. And for the z, if we remember earlier, the height is 2.5 meters. So we will change this to 0.000 to 2.5. So for the labels, since we have 9 grid, we will change this to 1, 2, 3, 4, 5, 6, 7, 8, and 9. So for the y, since it's only one line, so A only. And for the z, we will change it to plus 2.5. Then click modify, click yes, then click close. Now we have our grid line to make the modeling for the truss easier. So let's create a view, then click along grid lines. So let's create a elevation view so that we can easily model the truss. So click create. Then as you can see here, it's grid line A, so we will find grid A. Then we will transfer it to visible views. Click OK. There. We now have the elevation view for our structures. So now we will add column. So in this example, you can use any type of column you want, but for this, I will use a concrete column. So click the concrete column. Then on the grid 5, it has the highest elevation, so I will click it right there. Then to change the property of column, we can double click it. After that, click position, then change the top level to 2.5 since that is the height of our column. So click modify, then click OK. After that, let's create more columns. Click here, 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 like that. Then since it is triangular truss, we must change the height of these 6 columns. So for the height of this, let's change it to 0.626. So this height is this height resulted from the use of Rayleigh proportion. So click that. For this, let's change the height to 1.251. Click modify. Then click this. Modify again. And for this column, let's change it to 1.875. Then click modify. click the other column, click modify, then click OK. After that, let's create the beams. So let's use a concrete beam again. Then let's model this. You can refer to the figure earlier. So this will be like that. Click. Then let's connect the beams and columns. So it is important to note that we need to click on the center of the column in order for the nodes to be accurately created. So like that, top, that. Then for the other side, by the way, you can use any method that is more convenient for you, but in order to show it to the beginners, I will use this method of creating beams. Click like that. Then we will create the diagonal lines. So it will be like a hoe truss. So click like this to the center of the column. Click here and here, here and here, here and here, here and now we have our truss. So now we will change the member properties of this. So to easily do that, we must click here. If you can see this standard. After clicking, a menu appears. Then we will select beams. So first, let's double click a beam. Then let's change its profile or its cross section to let's say 200 by 100. Then click. After setting like that, we can select all beams. So since we selected beams, it will only select beams. So click modify, then click OK. So for the columns, let's do the same, but this time let's find the columns. That. Then double click a column. Then change this to, let's say, 200 by 200. Then highlight all the columns. Click modify. Click OK. So as you can see, since we selected the columns, it will change into the height of the highest. So that is very wrong. Let's ulit. 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 Pakat dun sa game. 3, 2, 1. 3, 2, 1, action. So now let's select the columns. Let's say 200 by 200. Click modify. Then click the other column. Nope. Let's undo that. Then 200 by 200. Click modify. Click OK. Then click another column. 200 by 200. Modify. Okay. Click 200 by 200. Click 200 by 200. So now we have our truss. So after that, let's go to the analysis design to create the loads. So click on load, click on point load, and at first just click the top part of the columns again, and we will modify it later. So for the first one, we will use px is equal to 6. So let's 0 to positive 6, modify, okay. Then double click the second one. It's pz, since it's downward, use negative 27, modify, click OK. For this, negative 30, downwards, modify, okay. So for this, I made a mistake, so there's no load there, so we will delete this. So for this, we will, since it's parallel, perpendicular to this these beams, so we must compute first the x and y components. So the computed components for px is negative 44.246. Oh, negative. And for pz, it's negative 23.287. Click modify. As you can see it's now diagonal. Then click this load again, modify, then modify. So in order to better see the loads, we can change the color of the loads. So by clicking load groups, then the color, let's change it to black, then click OK. So now we can clearly see all the loads. After creating the loads, we will now get the analysis we can now input the supports. So when we refer to the figure earlier, we have a hinge here, a roller here, and another roller here. So to do that, let's click this beam. Let's first return this to standard. Then let's select all of them. Get analysis properties. Nope. Just select a member pala. And click get analysis properties. Then let's change the start releases to connected and end releases to connected, since all of them are fixed to each other. So select everything, click modify, click OK. So for the hinge here, let's click this column, then click get analysis properties. So we must have a hinge here. So since this is the end release, as you can see in the color, this must be the start release. So let's change the start release to a hinge, then click modify, click OK. Now for this, let's create a roller. So click get analysis properties, then start release again, then let's create support condition supported. Then since it's a roller, so the ux or the displacement on x is free. For uy, it's also free. For uz, it's fixed. So this will be pinned since rollers have no moment. Modify, click OK. After that, for this part, we have a roller here. Let's click get analysis properties, and this time it's end releases. Then click again this pencil icon, support condition supported, roller free, fixed, and pinned. Click modify, click OK. Now we completed the figure. So to analyze it, let's go to A and D models. Click the A and D models. Click new. Then let's select SAP 2000 for our analysis application and full model. So click OK. There, as you can see, we can now see the analysis model of the truss. So if we import it to SAP, this will be the resulting model in SAP. So we can see here we have let's check. We have a support here, support there. Then let's click export. So let's click no in here since we're only looking for the support reactions. Then let's wait. Oops. So